So what we'd love for you to do at this point, and I'm going to turn it over to Yash, is for you to go through the CanLead 8th grade illustration. And so while you're going through that, we're actually downloading some molecular workbench simulation. I want you to start thinking about what did the technology help you do if you're going through it as a student. How can simulations augment your teaching and sort of augment your students' thinking? Any questions or comments? Well, I have okay, so I'll turn it over to Yash.
Thank you. Okay, so I'm at the 8th grade illustration for simulation. So TPAC for simulation, 8th grade illustration. And just like Bart did, we're going to go ahead and go to try simulation. Okay. And so you have a purpose, general overview of the simulations that are used, learning objectives, and then let's just go and jump to the activity guide. And so the first thing that we need to do is download the actual frame for the simulation. So we're going to download Molecular Workbench so you can access the simulation. So if you click on that first link, it'll take you to the Molecular Workbench website. And if you don't have Java on your computer, you'll have to install Java and then Molecular Workbench for PC. But if you just have a Mac, there's a one-step link that'll download the application for you. So if you want to do that, feel free. If not, you can follow along with me. I'm assuming you have it.
You can go ahead and install it.
Okay.
Okay, so anybody having any trouble?
But you're going to come up with a new.
Well, I went to what?
But you're going to come up with a new one.
Well, I went to school in Melbourne, but I got one of the classroom.
Okay, so you guys can see that at the home page, there are a whole bunch of featured models, featured activities that you can go through. I'm going to show you just one activity, so you guys can kind of get a hang on, okay, what's this all about, what do I do with this, if you're not familiar with it already. Okay, so if we click on browse the entire library, and physics, under the category, subcategory physics, we'll do heat transfer.
Physics was wrong.
Yep. So one more time. Physics, and then under physics is heat transfer. And we're going to do a continuum simulation. We'll do comparing thermal conductivities. So one more time, and this is all on the Try It simulations page, but if I go back, I'll take you one more time through it. Under physics, it's heat transfer, and under continuum simulations, it's comparing thermal conductivity. And you can see there was an extensive list. There are many topics that you can use. And then go back to And on the actual Try It page, there are a bunch of questions that the students are guided through. I'm going to let you guys actually play with that for a second. So if you go to if you go back to the CanLead site, under the Try It page, we're going to be on part 2, comparing thermal conductivities. Okay? So there are some warm-up questions that you can think about, but if you go through the actual activity and try to answer the questions, You want to do that?
Sure. Why don't we spend a couple of times, why don't we spend at least 5 minutes and let you sort of explore either that simulation or you could explore
Or just
something
any
else.
simulation.
And we'll come up.
The temperature of the zones around it, things like that. So if you, there's another thing you can do. If you stop that and reset it, you can move the zone around itself. So, well, you move thermometers, but the zone itself can be moved. So, yep. And so if you place it there and run it, you can see that, and you can move it around while the simulation's running. So it kind of shows you the shift of the heat flux lines, the shift in isothermal temperature as you move around things around. So as a teacher, you can come up with, if you don't like the questions, try your own questions for any lesson you want to do. And too much time to play with this,
And it's good as it goes faster through the zone 2 and the zone 1.
Okay, so some of you are kind of playing around with it, kind of getting an idea of what's going on. Let me show you the full capacity of all this. So under initial conditions, we have zone 1, and the left rectangle is a conducting zone. Okay, and my heat is going to come from the top of the simulation. My heat source is at the top of the simulation. So if I just click run, students get an idea of, okay, this is my right zone is a hotter zone. I can tell by the color and also by the temperature gauge that, okay, the right-hand zone is a hotter zone, and so he is coming down a little bit faster. And I can see all the temperatures changing in these zones. Okay? And if I click on show isotherms, it shows the rate at which the heat is flowing through each zone. Okay? So in the conducting zone, in zone 1, since it's a conductor, the heat is flowing through a lot faster. Okay? And therefore the temperature is okay. I can also show heat flux lines, which show the direction of the way the heat is moving. Now, heat flux lines are generally just perpendicular to the isotherms. So you guys can kind of see that the isotherms are kind of horizontal across the page, and the heat flux lines are vertical across the page. And so, but the heat flux lines aren't really necessary to look at for this one. So that's just under normal conditions. Now, what I can do is I can change the conductivity of the left triangle. So if I reset, and I'll change it to a much lower conductivity, I can run it. And you can ask students, well, how is this different than when the conductivity was at 1? How is this different than having a high conductivity, between low conductivity and high conductivity? Furthermore, I can move my thermometers around. So if I click on a thermometer, I can move it anywhere I want. Okay? And this is true for all the thermometers. So let's say you want to explore the temperature of a certain zone right after the conductor. You don't want to wait till it gets to the bottom of the simulation. Okay? Or you want the temperature, you want to measure different temperatures in the conducting zone itself. So you can move the thermometers wherever you want. Not only that, you can move the conducting zone around. So if you just click on the conducting zone, you can move it around. So you can change where it's being conducted. So if I stop this and I reset it, and I'll run it again at a high conductivity, okay, I can change my zone, and I can change it during simulation. So let's say this is my conducting zone now, I don't want it there anymore, I want it here, I'll move it. And students can see, okay, how is this affecting heat flow? So that's kind of the stuff that is available to you. And there's also a timestamp up here, which lets you know how long the simulation's been going on. It's kind of arbitrary. I don't really know what it goes by. But.
So maybe to get you guys started, we're going to let you fill out the sheets again about simulations. But I wanted to get back to some of the questions. So how might simulations help students learn? How much you think that some of these simulations, what are some of the affordances of simulations? Does anybody have any ideas after trying these heat, and maybe even some of the FET, looking at the sound one? Do you have any ideas? Yep.
Well, the simulation, you don't need all the scientific tools to sit there and measure that. You know, you don't have the thousands upon thousands of dollars to purchase the tools. You know, and then say, I'm going to use it for all these different classes. Each kid needs their own. You know, this way they can all apply in different ways.
Absolutely. So the setup required to do a physical lab, perhaps, can be daunting at times. Since as a former chemistry teacher and physics teacher, it takes a long time. That being said, I still think I love physical labs, but you can conduct experiments really quickly and really easily with appropriate setup with these types of simulations, right? Wonderful. Yep.
Well, I'm a non-math person, science person. So for me, a lot of times I think when kids are doing experiments, they go through the motions, but they don't know what they're doing, or the end product. So for me, this lets me see the big picture from the beginning. And then if I were to go do a physical lab, I would kind of know what I'm trying to do.
Absolutely.
See what I'm, yeah,
Absolutely.
so-
Wonderful. So now you're starting to think about, how can we start to use this in instruction? And yeah, research has actually shown if you pre-teach like physical labs with these kind of virtual labs, it augments student understanding. They learn more from the combination than they do either alone. And that's just like what you were saying. It sort of primes them to think, as a scientist does, about heat, right? So now they can kind of see these isotherms, or they can kind of see the waves.
Yeah.
Absolutely. So that brings up a really important point, that these aren't, so how many people, you may not want to admit this, I had trouble making sense of this. Did anybody else have trouble making sense of this? Absolutely, right? So these aren't used outside of good instruction, right? So if you just give them to students, they're not going to magically learn. And so we want to make sure that we get all that TPAC in, and that's where the curriculum packages, the CanLead packages, really try to help foster, okay, well there's a great technology, but how is this going to be integrated with pedagogy? How is this going to be integrated with the content? So with that, we'll let you discuss.